Hi! This instructional video is about solving quadratic equation, this time by the most dreaded complete the square method. Yeah, so here's one example. X squared plus 20x plus 104 is equal to 0. We're trying to figure out what can you possibly put into this x and to this x so that when you evaluate them, it'll become a 0. Here's how we start off. First, take the constant c, and we're going to move it to the other side of the equation. So in this case, we're going to go minus 104 to both sides of the equation. So what remains on the left side of the equation is x squared plus 20x. Now here's some things that I want you to follow my recommendation. Plus, leave it blank, equals, leave it blank, minus 104. Okay? So what goes into this blank? What you're going to do is take the b of the quadratic equation, in this case the 20, and you're going to take half of it. Take half of b, or divide it by 2, and whatever you get, square it. And that becomes a perfect square. So in this case, the b is 20. So you're going to go 20 divided by 2, and you square it. Well, 20 divided by 2 is 10. And if you square that, it's going to be simply be 100. And that is what's going to go into the c. You're forcing it to become a perfect square. So you could factor. But whatever you do on the left side, you do on the right side as well. So now that we have a perfect square trinomial, let's go ahead and factor that to show. We could skip this part, but I want to show it step by step. So the question is, what times what gives you x squared? That'll be x and x. Now we go to the c. What times what will give you 100? Well, we know that already. It's 10 and 10. And the question is now, 10 and 10, what must their signs be? So if you combine them or add them, it becomes positive 20. Well, they both have to be plus and plus, and they will always be identical. Now let's evaluate the right side at the same time. 100 minus 104 is simply negative 4. Now, since these binomials are identical, we're going to write that as a square, x plus 10 raised to a second power. Nice and neat, isn't it? Now we could start solving for x by getting rid of all these outside things. And then let me write this one more time to reduce the clutter. So now to solve for x, we have to do the inverse of a square. To do that, we do the square root. And whatever you do to one side of the equation, you have to do it to the other. So square root of a square of a binomial, the binomial just comes out by itself. Yay! And on the right side, anytime you take a square root of any number, there's a possibility of being a positive or a negative. Okay, now square root of negative 4. Now let's think about this for a second. We have a negative radicand. Now from the previous instructional video, we talked about the imaginary numbers. Where we defined the letter I as being square root of a negative 1. And based on that premise, we could simplify the square root of negative 4, because isn't square root of negative 4 same as saying square root of 4 times negative 1? And I know what a square root of 4 is. It comes out as a 2. Yay! But we also said square root of 1 is same as saying I. So in fact becomes 2i. So now let's rewrite that as plus or minus 2i. Now we're going to solve for x by moving the 10, so we go minus 10 to both sides of the equation. So what we in fact get is x is equal to 10 plus 2i, or 10 minus 2i. And that becomes a two possible solution where if you substituted one of them to here and here, it'll become equal to 0. Yeah. Now that you saw that, let's have you try this guy. Okay. Now, the thing is, in this case, we have an x and the x on both sides of the equation. So we have to put them together to make it look like what we had originally over here. To do that, let's move the 2x to the left side to combine them. So we got minus 2x minus 2x. So when I rewrite, we get x squared minus negative 4 and negative 2. They're both negative, becomes negative 6x. Plus, leave it blank. That's going to be our c term, which will force it into a perfect square. And that equals, well, that's gone. On the right side of the equation, leave it blank. Plus 35. Because whatever we do here, we're going to do it on that side as well. So what goes in here? Well, we're going to take the b, just like before. Take the b, which is negative 6, and we're going to take half of that, divided by 2. And whatever you get, you're going to square. This is called complete the square. We're going to force it. And negative 6 divided by 2 is negative 3. Some kids who realize anytime we take a square, it's going to become positive. Doesn't matter if it's negative. No, it doesn't. But I'm just going to show it through, to be consistent. So negative 3 squared is 9. And that's what goes in here. And whatever you do on the left, you do it on the right. Now we could take this perfect squared trinomial and factor it. So the question is now, what times what is x squared? That's x and x. What times what identical gives you 9? That's 3 and 3. And what must their signs be? So if you add them together, becomes negative 6. They both have to be negative, negative, or minus and minus. And on the right side, let's evaluate. 9 plus 35 is going to be 44. Now, since this is an identical binomial, we could write that as a square. And that's 44 on the right. Now, we're going to, let me write that again twice to reduce the clutter. And now we're going to solve for x by doing the inverse of a square, and that's going to be square root. So when you do the square root of a square of a binomial, the radicand binomial x minus 3 comes out by itself. As I said before, anytime you do a square root of any number, there's a possibility of being both plus or minus. And let's do this right here simultaneously. 44, square root of 44, isn't that like saying square root of 4 times 11? And square root of 4 is 2, so 2 comes out. Yay! 11, well, 11 is a prime number, so it's not going to come out. So we got 2 square root of what remains inside as a radicand is 11. Now, we're going to solve for x by doing the inverse of negative 3. Additive inverse is plus 3 to both sides of the equation. So your answers are going to be x is equal to 3 plus 2 square root of 11, or 3 minus 2 square root of 11. And those are the two possible solutions. If you took one of those binomials and substituted into x squared and x, and to this x, the left and the right will equal, making the statement true. There it is.